Welcome to the Ducks Unlimited podcast, the only podcast about all things waterfowl. From hunting insights to science-based discussions about ducks, geese, and issues affecting waterfowl and wetlands conservation in North America, we bring the resource to you. The DU Podcast with your host, Dr. Mike Brazier.
We are rejoined on this episode of the Ducks Unlimited podcast by Dr. Susan Ellis Felege, Associate Professor of Wildlife Ecology and Management from the University of North Dakota. We had Susan on a previous episode to talk about some of the nest camera research that she and some of her students are involved in on the prairies, and we did not have much of a chance on that episode to talk about some of the other really neat technologically based research that she's involved in. And so we have her back on this episode to talk about that. And specifically, we're going to be talking about drones and the application of drones to study waterfowl, both up in the Arctic as well as the prairie. So Susan, thanks so much again for sharing your time and for joining us.
Yeah, thanks for having me.
We will jump right in here. We'll encourage folks to go back and listen to the previous episode to learn a little, or the other episode that we had with you to learn a bit more here about your work, where you are and what you do and how you kind of came to your position in this profession. There was some great information there. But for this episode, we're going to talk just about some of the drone research. Dr. Rocky Rockwell on a previous episode encouraged us strongly to get you on to talk about some of this research. He is a big fan of yours. He's a big proponent of the research that you're doing with these unmanned aerial systems, and he sees great potential in it. And so next time you see him, you can thank him for partly, now we already had you on our list of potential guests, but you can certainly thank him for giving us the extra push to get you on an episode sooner. So keep that in mind next time you see Rocky. So let's just start by you telling us about that research in the Arctic that Rocky was referencing. What does it involve, and how did it all start?
Yeah, so we originally started in about 2015 it was. I was talking to Rocky about different potential ways to take and explore the exploding snow goose population. And this is just outside Churchill, Manitoba, in a part of the Wapusk National Park, where snow geese have gone from 2,500 nesting pairs to more recently something like 75,000 nesting pairs. And so some of the old ways to which Rocky used to go around and count nests and do things are a lot more logistically difficult to do and very expensive if you have to use a helicopter to get around. And it just takes time to traverse the landscape and to get to each of these different areas where there's now nesting snow geese. And so we started thinking, well, what tools could we possibly use to address different questions about how many snow geese are there and nests are there, and even, what's happening to the habitat? How much damage is really occurring? What does that look like? How much recovery? And so I was at the time exploring drone use for an opportunity to say, okay, what are some different directions we could do this in wildlife ecology? And so it was a natural, great opportunity to partner with the Hudson Bay Project and Rocky to explore those questions.
When did this, or you had a graduate student involved in that project, right?
Correct. Yep. So we started in 2015. I had a graduate student, Andrew Barnes, who is now Dr. Andrew Barnes. He finished his PhD here in December. And he has been absolutely instrumental in facilitating, what we've learned about snow geese and the use of drones, and even using drones to explore some of the predators such as polar bears that you heard from Rocky talking quite a bit about in one of his episodes. So what we set out to do, the first thing, when we proposed using drones to the national park and the community, everyone was like, whoa. Because there had been a lot of videos, if you look on YouTube and whatnot, where people were actually chasing wildlife and kind of using them with a little bit of unethical approaches, we'll say. And so we had to first demonstrate to the park that we were doing this and we wanted to learn about the animals, but we didn't want to disturb them. And there's a large cultural respect for these animals where if you don't touch them, don't disturb them, that's really the appreciated way to do science and do research. And we were very aware of that and really wanted to support that. And so that was one more reason to use drones as a possible tool. But there remains a huge question. Well, do the drones actually impact behaviors? And most of the work that had been done on any behavioral research back in 2014, 15, even 16, really was based on a lot of times people flying at animals. And that has some merit, but it doesn't really answer the question. If you're going to do a traditional survey at some given altitude that fits your objectives, does the animal seem disrupted by that? Are they cueing in on it? What's happening? And so we used essentially these miniature cameras that we talked about on the last episode that I was here, that are surveillance cameras from the gas station. We placed them at snow goose nests, and then we went out and we placed them in places where we would fly. And what we were doing, we were flying a fixed wing aircraft. So everybody you see typically has small little Phantoms that DJI produces. We were using it was originally made by Trimble. If you look at it, it's this big, basically styrofoam fixed wing. It's about a meter or yard kind of in width, weighs about 4.5 pounds. It takes off on a catapult. So you basically take elastics and tighten them up, launch it out there, and then it goes and runs a pattern that goes up and back, up and back. Just if you think about what it looks like mowing your lawn, that's essentially what it's doing. It's going up and back to be able to make sure we get images, and we're overlapping the images so that we don't miss anything. All right. And then we can make a big map out of it and go back and count how many snow geese were down there. And so we did that across sections of the national park up there where we had nesting snow geese. And then when the aircraft was done, it belly lands or crash lands, if you would, comes back. We take the images off of it, and we can review them. And so we were able to ask the questions, well, do the birds even pay any attention to it? And what we learned, they weren't getting off the nest at least a whole lot from when the aircraft was in the air. If they got off the nest, it was typically when we were sitting there setting the nest or the equipment all up. And when they did get off the nest, if a predator flushes a goose, typically the goose gets off like the house is on fire and they're out. What we saw on camera was that when the goose did get off, it took the time to cover its eggs with its down, so the breast feathers, covered them up, and then it slowly would meander off. And so it gave it time to cover it up and protect those eggs from any predators that might be looking, especially aerial predators like gulls. But it also meant that they were being thermally protected because up there it's still pretty chilly when the geese are nesting. And so that was pretty cool. They did notice if they sat there, though, they would look up and do this kind of overhead vigilance of, oh, there's something up there. But otherwise, that was the major thing that we saw.
Did the gander have any kind of behavioral response that you were able to see, or were you unable to pick that up with the camera?
It was inconsistent on that part of it. We mostly focused on the female because a lot of times the gander was out of the field of view of the camera, so we couldn't consistently get that. From some personal observations, sometimes you would see him step out away from the nest, do some honking, even pull his wings out a little bit if it got really close to them. I noticed this. We had one landing that literally kind of flew over top. The female didn't even flinch, but the gander did sort of puff his chest up like, oh, what was that? And then just calmed right back down.
What's the altitude that you're flying this the drone? You might have said that and I just missed it.
No, I didn't. That's a great question. So we were flying. So our aircraft was limited to not flying lower than 75 meters or 246 feet above ground level. All right. So we were limited to basically 250 feet above these birds. And then we could fly up to 400 feet based on regulatory permissions with the Transport Canada, which is analogous to the FAA up there. So we kept it within 250 to 400 feet. We did not notice that altitude made a very big difference in terms of the birds' responses. I think we were up there high enough that really the birds noticed something was happening, but it didn't pose a huge threat to them. And so there wasn't a whole lot of differences at those altitudes.
Was that minimum altitude something that y'all came to agreement with, or y'all agreed on with the park system?
It was actually a system requirement. The way that Trimble had designed their aircraft to minimize low flight problems was that they allowed it to, once it got up to altitude and was flying, you cannot program it to go below 75 meters. And this is something that essentially it's all pre-programmed. So you pick your area that you want to fly and you can make the aircraft go off the course and whatnot. But from an altitude standpoint, you cannot make it go less than 75 meters or 250 feet, basically, without it coming in either on takeoff or landing.
I've actually seen this at least I think it's the same one, seen this drone at a previous sort of field display, field exercise associated with a Ducks Unlimited, Ducks University type of summer field session. And it has somewhat of, I guess the profile, the shape of it reminds me of a stealth bomber. It's kind of that triangular shape. It's black. It's either stealth bomber or kind of Batman type theme. But one of the questions that folks might have, certainly I did, is how loud is this thing? I guess, and maybe that's relative to the altitude that it's flying. When it's flying up at 75 meters, can you even hear this thing as it goes overhead?
Yes, you can. The interesting thing about sound and noise, if you would, is that it's really heavily dependent upon the conditions that you're in. Sound carries differently based on the wind, as well as even how much moisture is in the air. Whether it's flying away from you or towards you, you get some different aspects of sound. Originally, our research, we wanted to explore it, but the sound piece actually became really difficult to disentangle. To me, it sounds like a mosquito up there. And you can definitely hear it buzzing. And most of the animals, so we also did this on polar bears, and we flew over top of polar bears as part of our work up there when we were doing some habitat assessments. We did some behavioral work on polar bears, and they pick up, and you can tell, like, they hear it coming, they look up above, they watch it go over, and so it just sounds to me like a big mosquito going. And then if it's lower, it certainly sounds louder. And then if it's less windy and kind of a quiet day, you notice it. The other thing you notice is the motor will sound louder when it's turning, because it's, making the sounds to essentially, fulfill its flight requirements. And so as you hear it taking off, it's a little bit louder because it's really propelling the engine. If it gets a little bit more of a tailwind to it, sounds a little bit quieter because it's trying to slow itself down.
Well, let's see. What else do we want to talk about that? Major findings, have the results from that research changed the way Rocky is thinking about doing some of those surveys, or what are any of the other kind of key findings from that work?
Yeah, so I mentioned a little bit, what we did learn is that there's some clear ways that we should fly, and we're able to give the park some guidance. I think that there are some different drone things that you don't chase wildlife, but you can do a survey very effectively. And for the sake of polar bears, they weren't running and, taking off. And the geese certainly weren't either. And so that was one important finding, was generally speaking, the animals noticed the aircraft, but they weren't really flushing and whatnot. We also flew over common eiders as well. And the eiders up there that nest right near the snow goose colony, but not necessarily overlapping with it anymore, nest in some willows and birch on these little islands along the Mast River there that feeds into the Hudson Bay. And with them, they had some overhead cover. And what we noticed with them, they really didn't respond at all. They didn't get off the nest. They didn't even look up much. They didn't change any kinds of behaviors. And so what I think is a big take-home about bird behavior and what we fly is knowing some of those habitat differences may make a difference in how birds will respond, waterfowl species in particular, to these different, aircraft. It may heavily be dependent upon how safe they feel and what they can see versus hear in those environments. The other really cool thing that we were able to do, and Andrew always pointed out, was when we went out, we did some vegetation measurements. And Rocky talked a lot about, trying to assess the damage that's gone on where the snow geese have eaten a lot of the vegetation, and it looks very much just bare earth, if you would, in many places. So they have some historic areas that what they do I think it's 3 to 5 years, about 5 years, I think is what we've been doing, where they literally walk these transects across this fairly large area. And you say, okay, every meter or step that you're taking, what is the dominant cover type? Or vegetation. Is it mud? Is it some kind of grasses or sedges? Is it shrubs? What is it? And so Andrew did this, and for 3 days, he and a recorder walked all of these plots. And then we had my husband, actually, Chris Felege, helped out as the bear guard, making sure, since their heads were down, that they were safe. Meanwhile, I hung out right by the camp and flew, and in 26 minutes, I covered everything that he did in a 3-day survey. Now, we had to bring it back, and a question that comes up with this is, how much data do you get? You get a lot. And, we flew a couple different altitudes and things. So I had a couple different 26-minute flights, if you would. But we came back and had about 100 hours of post-processing because we made maps out of it. And then we ended up, so we made these big, large maps, or mosaics, they call them. And then we also went through and categorized the vegetation and used tools like ArcGIS and some mapping tools. And what we did take home from it is that you can do pretty well with a lot of the vegetation assessments. And so doing work in the Arctic, you have a really, really limited window to be able to do a lot of field work. And so having a tool like a drone that could cover something where you got all of that vegetation surveys done in, a flight or two that took 3 days on the ground. And it also can reduce the time that if you have polar bears and other types of we call logistical challenges, it gives you another tool that maybe is safer alternative than having boots on the ground right there, or in a way that you're in a more confined space where you can be a little bit more vigilant than you are as you're moving across the landscape, where you might actually bump into a bear. So those were some really cool findings that we had out of that work.
I know Rocky talked a lot about the risk that polar bears presented to researchers up in that at that colony, and so the risk factor is huge. But also the 2 or 3 days that you're saving, given what you said about that limited time window, is also way more important than most people would ever realize. So that's pretty cool. One question is related to the spatial resolution of the imagery that you get back at that altitude. What's the spatial resolution that you're getting from that imagery?
Absolutely. So when you fly at the lowest altitude that this Trimble was going, and the camera that we had on it, we essentially would get each pixel, individual pixel within the picture was about an inch or 2.4 centimeter resolution. And then that went up to at 400 feet, you're probably a little around 2 inches or so, 2.5 inches. So where we did have some challenges, graminoids, which are grasses and sedges, those categories were a little bit hard to classify because they, if they weren't in real dense stands, you could lose them at a resolution that's that sort of coarse, if you would. Some might think that's really good, and on one hand, it is for shrubs and stuff, no problem. For the areas that we had a lot of mostly bare earth, no problem. But you did have a little bit of trouble if you had small areas where the graminoids were either just a small holdout of them that were hanging on, or some that might be recovering where you only had a few of them.
Do you know if Rocky is planning to use drones going forward as a replacement method, or has he kind of not gotten to that decision point yet?
I think he would like to. I think we're at a place right now where we have to figure out some additional funding to support the equipment. Some of the equipment that we used there was getting old, and so replacing that and having some more consistent, dedicated staff that can actually fly and whatnot is the next key step for him. But I know it's an adoption route he'd like to go.
Be the first to know when ducks are on the move. Sign up for DU's waterfowl migration email alerts and receive ongoing in-depth updates on the latest habitat conditions, weather changes, and hunting reports for your flyway. Visit ducks.org/migration alerts.
So just tell us about the drone work that's underway in the prairies.
Yeah, so in collaboration with Ducks Unlimited, we are working on a couple different directions with the drone work in the prairies. The first is answering some questions about behavior. As I mentioned, there was some stuff we learned about with a fixed wing aircraft. So that's what we were flying up in the Arctic. And it's a really great tool, but a lot of the fixed wing drones out there, they can cover a lot of ground, which is a benefit of them. So you end up getting a larger spatial area you can cover per battery. And that becomes a really critical thing in terms of your number of batteries, and especially in the Arctic where you only have limited resources to recharge things. But the one limitation is you can't put usually as many sensors. A lot of them right now, and this is going to change down the road, but a lot of the sensors or other types of cameras, like thermal and whatnot, are really only being supported by rotary wing, quadcopters, octocopters, hexacopters, things that have multiple rotors and can do vertical takeoff and landing. So thinking more like the quadcopter, the Phantoms you see on Amazon. And so that poses its own questions. You mentioned the description of the shape and style of the aircraft we're using. Well, there's a fair bit of research that suggests that something that might look like a bird that's an avian predator type thing, like a raptor, for example. We've talked about that. That could look like a threat to an animal, and a nesting bird in particular. And so one of the questions that still kind of remains is, how do birds respond to these different types of platforms? If you fly them at the same altitudes, the same conditions, what's going on behaviorally with them? And there's a lot of things suggesting that it's very species specific. I mentioned the snow geese who were nesting out in the open. They were certainly looking up a lot when we would fly, but the eiders didn't really pay attention at all. And so one of the big questions that remains for me was, well, okay, if we have different aircraft and across some different duck species that are all nesting in the prairies, how are they going to respond to that? So I have a new graduate student, Mason Reichman, who actually is about a year into his program. We did our first work on this last year where we flew over some of these nest cameras that our undergrads were deploying out on the Nature Conservancy's land and DU's Coteau Ranch. And we started asking questions about when you fly a quadcopter, which we have a Matrice 200, which is, it's got 4 rotors. It goes up and down, has about a 25-minute flight time compared to something that's rated more like 45 to 50 minutes with our Trimble fixed wing. But we flew each of those over birds that had these cameras. And then we also had birds, of course, we didn't fly over for comparisons. And we're asking questions about, do they behave differently? And so we are seeing that birds seem to hold still quite a bit, the nesting hens. And we think that regardless of platform, there may be some aspect of they hear it, they don't know exactly what it is. And so much like an approaching predator, they don't want to reveal their position, so they might not move quite as much, but then seem to resume normal activities, after that flight is over. Now, it's very preliminary data right now. We only have a small sample size of a little over a dozen birds to kind of conclude from that on the behavioral responses, but we've got a full season ahead of us this summer to collect some additional data and then start asking questions about blue-winged teal and mallards and maybe even gadwall to see if they're responding any differently. So that's the core part of what we want to know is the question about the behavioral responses there.
That is cool information. I was not aware of much of that. I know you've got some other things to tell us about, but I want to ask you a few questions about this. So the first thing that I'll do is piece some things together for our listeners that may not have yet listened to the previous episode where we talked about the nest camera research. If you haven't, then what you just described is tied back to that. So you have these nesting females. You know where these nesting female ducks are based on the nest searching and location of the nest. And then you deploy these cameras at these nest sites, and that's where you're filming the hens, watching what they're doing on these nests. So that's how you know where the hens are, and you can use that information to know, kind of where you fly over them. Then you're looking for that behavioral response. That's a very cool marriage of two different technologies in itself. The one question I have is whether maybe you're going to talk about this, but are you using infrared sensors to look for these nests, and are you able to see the females through the vegetation? I know we've done we've tried that on the Gulf Coast. We haven't been very successful with model ducks. So are you looking at any of that on the prairies?
Yeah, so that's another arm of it. We've actually we worked with a group out of Rochester Institute of Technology in their imaging science program, and they actually brought a larger drone out, a Matrice 600, and it had a bunch of different sensors on it, including a thermal camera, infrared, and we actually explored some different altitudes to which you really need for a lot of these thermal cameras that are small enough to fit on your drones that you're using for this type of application. And yes, you can find them, but it is challenging. And the trade-off and challenge that we're seeing is you're going to have to be, something like 100 feet above in many cases these nests in order to say, okay, there's a nesting female there. And there's been some other work that Delta Waterfowl is also pursuing in some of these questions. But what you find is that it looks like you're going to have to be at about 100 feet. And then what that means for some of these aircraft, most of which are rotary wing, and I mentioned have very limited battery life. When you're low like that, you have a very narrow window in terms of your search window as you're going up and back searching an area. And that translates to you not covering very much ground. And so there's going to have to be some technological advancements here in either higher resolution thermal cameras or a little bit of figuring out the best times to do it, that you get the best contrast. What a lot of people don't recognize about some of these thermal cameras is that they think they're getting like an absolute heat signature. You're not. You're getting a relative one of a heat signature of that nest relative to like what the background is. So if the background's really hot, it makes it harder to disentangle a nesting female where she might be there. And remember, female ducks are really well insulated. So that might actually make it hard to see some of the heat. And so we just obtained a night waiver to be able to do night flights and are exploring the searching from a night perspective to look at whether or not we can figure out the time. And this marries again back to our behavior. One of the best times likely to do these searches is right before sunrise. Do you know what ducks are doing right before sunrise? They're getting off the nest. Our nest camera research suggests that that's the one primary time, at least where blue-winged teal and mallards frequently go and take a recess. They take a break.
It's really predictable around that sunrise time?
Yep, it's pretty predictable. And so what does that mean? If your best times maybe to locate their nest, you're going to have to figure out, well, is the heat still residual enough to pick it up? And will you see that nest if it's uncovered? Maybe you'll see it better. There's been some work that suggests that, that heat's contrasting without the hen sitting on it. And so this is really cool where we get to marry these two technologies, as you kind of mentioned. What we're learning about their behaviors is helping us to know how we can use these other tools to better understand what's happening on the landscape. How many duck nests are there? Where are they at?
Yeah, that's pretty fascinating. And that was, I was new to any kind of infrared technology. I knew nothing about it and really still don't, other than kind of what it looks like on the screen, be able to understand some of what you were talking about with respect to what it's actually measuring, relative temperature differences of the different objects as opposed to an absolute temperature. That's what I went into it thinking. But then very quickly you realize, oh, no, that's not what it's measuring at all. And so, yeah, there are some pretty real challenges in that regard, and you touched on all of those. Let's see what else from the drone research on the prairies would we want to talk about?
So I think the other direction that's an interesting one and one that I'm working with, thing that keeps coming up. So we collect massive amounts of data in this automation process. What do we do with that? And so one of the other arms of Mason's work is actually doing some pair counts on wetlands and asking some questions about, first off, what are the combination of altitudes and actual flight protocols you'd need to be able to tell that you have, a hen gadwall versus, say, a hen mallard on some of these wetlands. And then the next question is, okay, somebody sitting there and staring at all this imagery, you're not going to get very timely results as you would if you could have a computer go through it and whatnot. And so developing the AI or neural networks, people call it a lot of things, machine learning, developing those. And so that's where some of my partnerships with Rochester Institute of Technology, where I've got computer scientists and image scientists, we're actually exploring some questions about not only how do birds behave and how might that impact some of our counting, but secondarily, how do we make this a process that biologists can adopt and actually use in a timely manner for saying, okay, here's what the status on the prairie is for breeding ducks. Everybody wants to use a drone to do a lot of things. But fundamentally, we have to step back and ask the question of ourselves, is that the best tool? And is the current technology going to, address what you're really wanting to do? And I think right now that's an important consideration. The other consideration is that you need to develop and have the drone and the sensor combinations to meet those questions. A lot of people will buy something and say, I've got a drone with this particular sensor, and it's kind of like having a hammer and you're looking for a nail. You need to develop these in a way and think about using them to address the question that you have to do. And so some of those things are, well, what even are the best combination of altitudes and what is the resolution you need to find how many, count how many hens are there on a, in a given field or whatever, nesting hens. I think that understanding what resolutions and things, eventually the technology is going to catch up to where we can fly higher. We can do this on larger scales. But we have to understand what the bare minimums are to develop and design systems and survey methodology that will meet those questions. And I think that's kind of where we're at right now with the technology. And then the other piece is it's about the data. and you're collecting massive amounts of data. And I think that next wave of everything that needs to happen is developing these different automated procedures to manage that data.
Well, that's very cool. And it's not unique to these unmanned systems, this idea of, we have this fancy new technology, let's use it. Let's use it for everything. It should be able to answer all the questions. That's just sort of the natural tendency. And we've seen it in other telemetry technologies. And of course, you kind of have to do that at some level to learn and gain experience with it. But then there comes a point, as you're describing here, where you have to say, okay, we've learned about its capabilities and what they are not, more importantly than what they are. And so then you just kind of have to take pause and say, where do we need to go to answer with this technology in order to answer some of the questions that remain outstanding. So, I have a few questions here. Our producer, Clay Baird, handed me some questions, actually based on some of the conversations we've had over these last two episodes. So I have a couple of these that I want to ask you. And let's see. The first one will be, and you can talk about any of this research, whether it be the Nest cameras or the drones. What are some of the more surprising observations that you've made as a person that have really surprised you and as a researcher?
I think from the Nest camera standpoint, it's been really interesting to see things such as the blue-winged teal. After a nest gets consumed, a blue-winged teal will literally carry each eggshell out looking to see if anything was remaining. And that really can alter what we think happened at the nest. That was a really fascinating thing, that these birds are coming back and altering those nest contents, and really evaluating the scene of their nest. On the drone side, I think just the process of learning about the flight capabilities, the data management, I think that by itself, that is just, it's an interesting journey. I don't know if it's the surprising things you find, but it's a journey to what their capabilities really are, and what your data needs really are. It certainly makes you think about, what questions are you really answering? And I think from the drone standpoint, some of it is just how much even our presence in an area can impact things compared to the flight. Our behavioral observations are suggesting from those snow geese, things that, us over there clanking away might be the more disruptive things. So maybe the tools we use in terms of how we deploy a drone, is really more important than what's happening once the drone gets up there. And so that's kind of some interesting, surprising things in that realm. The other thing is just how much data you can collect. I think everybody needs to recognize they almost need a computer scientist as their partner when they do anything with this stuff, either of these tools. That is an absolutely critical piece. And what are you going to, how are you storing this data? Hundreds of thousands of hours of video. That's something that a lot of researchers that are embarking on some of this might not think about. And the other piece is, once you actually take the images on the aircraft, images by themselves takes up data. But when you actually start putting them together into products like a big map, and those maps can look at like digital elevation. So, what is the topography, hills and things like that? Those type maps are very large in terms of the data. They're very data rich, which makes them really big files. And so the management of those files and things like that are very surprising things for most people to recognize when they're using this type of technology.
Yeah, it's a bit more than Excel spreadsheets and GIS shape files nowadays, isn't it?
It is. It is.
I want to revisit your observation about the blue-winged teal removing eggs from the nest after a predation event. Does the female do that even after a complete nest destruction event, or do you see that behavior only if there are some viable eggs remaining in the nest bowl?
We find it under all conditions.
Is that right?
Most of them will come back and remove at least one eggshell out of the nest, regardless of whether there's anything left in there. It seems like, sometimes if there's a lot of eggshells, she'll remove several of them to make sure there's no eggs remaining in there. But we've seen it in many cases. I don't remember the exact percentage of it, but I would say most often a blue-winged teal will remove them. We don't see it as commonly in the mallards, and I'm curious to see what we'll see with gadwall.
How long will the female hang around the nest after a complete nest destruction? I mean, it's like, I guess the nature of my question is, how long does it take a female to process what has happened and say, all right, got to give up on this?
So it depends on the female. And I'd love to know more about whether she's an older or younger bird and things like that. We don't have that information. Some of them, like I mentioned, they'll come back and literally they'll take 1 or 2 eggshells, they'll leave, come back, and that'll happen over maybe a 5-10 minute period of time. Others we've seen over 2.5 hours of her coming back and, looking, and she'll take an eggshell out and leave and come back and leave and come back and literally take, 8 or 10 eggshells out of a clutch over a couple hours of time. And so it certainly can be hours. We haven't seen it lasting more than probably, like a morning or something like that, that so far at least.
Okay, well, the final question that we'll leave you with here is, how can people find out more about what you do? You are conducting some really cool research, and anytime you mention drone and cameras and all that, it really gets people's attention. A lot of really neat technology. So where can people learn more about what you do?
A couple different ways. Probably one of the best is that DU has been tracking a lot of what we've been doing relative to the prairies and ducks. And so there's been some kind of regular updates, and I envision more of that with the drone side of it. But certainly the Nest cameras have been something that DU has been tracking in a variety of the web stuff. We've even talked a little bit of nesting stuff with the magazine and the value of information there on nesting ecology. The other thing is, of course, our social media, our real duck tails, tails being spelled Tails. We've been sharing things that we've had out on the Coteau Ranch and the Davis Ranch here in central North Dakota. And that is on Facebook, Twitter, as well as Instagram. And so our students share a lot of the stories there. And so those are probably the 2 best ways folks can follow that. And then some of it's also shared on UND Biology's Facebook and Twitter, as well as the universities as they've come out and done some features learning a little bit more about what we do.
Well, I guess I do have one more question for you because I forgot to ask it. I asked it on the previous episode, but I need to ask it on this one also. With respect to the research that you conducted on in the Arctic alongside Rocky Rockwell, as well as on the prairies, who are some of the key partners involved in that research? Got to make sure we give credit to those folks.
When it comes to the Arctic, Rocky indicated this. It is a huge partnership up there, but the Hudson Bay Project, which is supported by a lot of the Central Flyway, the Mississippi Flyway, the Arctic Goose Joint Venture. All of them were critical partners on that. UND's College of Arts and Sciences, particularly my previous dean, Debbie Storrs, played an instrumental role in us being able to acquire some funding to get out of the gate, so to speak, and get some of our initial equipment and whatnot. And then when you get back to like the Churchill community, Rocky touched on them, the Parks Canada has been absolutely critical. We had folks at Hudson Bay Helicopters that provide us support. I'm sure I am missing some, but that group has been, it's a huge group of people who help support that whole Arctic project. And I was really fortunate to be a part of that. On the side of what's happening here in the prairies, again, UND College of Arts and Sciences supported some. Ducks Unlimited is the major player on a lot of that. As well as some of our social media, as I mentioned, is helped and facilitated through Southeastern Missouri State University and my collaborator, Sarah Kavanaugh. And then I also mentioned quite a bit of the automation side of this, which is supported through Rochester Institute of Technology, my collaborator, Travis Estelle, as well as a few other collaborators at RIT. So I've been really fortunate. Lots of partners, lots of partnerships. And then I also want to say none of the work that I can do could be done without a tremendous team of students, both undergraduates and graduate students who they're moving things forward. And without them, we couldn't be doing as much as we are doing. They're great. They're innovative. They bring a lot of fresh ideas and a lot of ties to the new technology. And they're very innovative. So I think a big shout out to the students is definitely deserved.
And that list of partners that you just provided is a great example of how in today's world, you not only have to be a great scientist, but you also have to be great at building and maintaining partnerships to do this work. And clearly you are. And so kudos to you. And I know Ducks Unlimited is happy to be a partner in the work that you do. And thank you for that. Thank you for all that work and for interaction with the students and DU. And we thank you again for spending your time with us. It's been great. We've had a couple of episodes, and I know there are still some other topics that we want to discuss with you, so we'll get you on in future episodes yet to discuss some of those things. So thanks again for taking the time to join us, Susan.
Yeah, thank you so much.
Special thanks to our guest on today's show, Dr. Susan Ellis Felege, Associate Professor of Wildlife Ecology and Management from the University of North Dakota. It was her second time joining us here on the show, and this time we were able to talk about some of the neat work she's doing with drones and unmanned aerial systems and all sorts of neat research on waterfowl. And we definitely appreciate her time and expertise in partnership with Ducks Unlimited. We thank our producer, Clay Baird, for the great questions that he offered to this episode, and also, like always, the great work that he does in getting these podcasts out to you, the listeners. To our listeners, we thank you for your time and joining us on the podcast, and we thank you for your support, passion, and commitment to wetlands and waterfowl conservation.
Thank you for listening to this episode of the DU Podcast. Be sure to rate, review, and subscribe to the show, and visit www.ducks.org/DU Podcast for resources based on today's topics, as well as access to more episodes. Opinions expressed by guests do not necessarily reflect those of Ducks Unlimited. Until next time, stay tuned to the Ducks.